Hello. It has been almost 2 months already since I started working on a game from scratch without game engines using C++ and Vulkan. And in that time, I already developed 10 features that I want to talk about it. C++ is actually not my area of expertise. I come from more high level languages, so things like pointers or having to manually manage the RAM by myself have been especially challenging for me. One of the very first things that I did in this project was to basically brush up my knowledge of C++ and write a build system that I can continue working on. In this case, I use CMake, and I also don't have a lot of experience using CMake, so I had to do a lot of tests initially in the project just to see if everything was working. So a video game cannot exist without graphics, right? Computer graphics is actually something that I have some experience with, mostly using OpenGL, but as you may know, OpenGL is quite deprecated at this point. So I decided to use Vulkan so I can use something more modern and robust, even though it was a pain to set up. So far, the renderer that I built is pretty basic when it comes to the result image, because I'm basically just drawing the vertices directly without using any shading or lighting. Because I am not using a game engine, I have to write my own 3D importer. The way I did this was I used the Python API from Blender to check the objects inside the program. And I wrote 3 different importers and exporters. One for the meshes that have vertex animation, one for the meshes that have transform animations, and one for the actual world data, like where is the floor, where is the camera, how many wizards there are, what are their positions. This is something pretty cool in my opinion, because I can just use Blender as basically the editor for this game. So everything that I do in Blender, every 3D object that I place, any changes that I do, I just run a script and all those changes are available in my game without me even having to rebuild the game. As I mentioned, using the Blender Python API, I can just export and import information, right? So I created this cool way of creating a world, which basically is a floor where the camera is and where the wizards are. Then there's the animation system, which in my opinion is pretty cool the way it works. So the same, I have different animations in Blender, right? They all have key poses, and Blender interpolate between those key poses. And those animations can be skeletal animation or transform animations, right? And the way it works is that I export all of those key poses and the transformation that happens on those key poses, like where the vertex were moved or rotated to, and all the other transformations like location, rotation, and scale. So I export those by keyframe, by animation, by object to my game. Then I upload all that information to the GPU using something that's called a store buffer, and I keep track in the game like where each object is supposed to look at when looking at which vertices it's trying to render. And all of that is based on which frame you currently at, which key pose are you trying to render, which animation are you trying to play, and which object is trying to play that animation. And all of that happens in the GPU. So in every game, you need a way to check if one object is colliding to another object. And sometimes it's not even about checking if they are colliding. You have to literally know how far away things are around an object in order to run some logic. Obviously, the naive approach will be to pair each object that you have on the screen, try to check the distance between that object and all the other objects in the screen. But that approach would be n squared in time complexity, because you are basically checking against every single object in the screen per every single object that is in the screen. So that is quadratic. So something that I implemented that in my opinion is pretty cool is called a spatial grid hash. And the whole idea is basically that you create a grid, and that grid can be a 2D grid. In this case, it's a 2D grid because I want to only check based on the floor, not really on the height. And you create this grid and you create like multiple cells, but those cells have to be based on the size of the word that you are using, right? In my case, is the floor. So the grid is the same size as the floor, and I divide each cells into some number, like something like 30 by 30 cells or something like that. And every object, you check if it is inside one specific cell. And instead of checking for all the objects in the screen, you check only the nearby cells around that object. The way I implemented particles in this game engine is that you define a maximum amount of particles that you can send to the GPU, but you don't send like all the mesh with the position and colors like you do when you are drawing a normal mesh. What you do instead is that you send a small version of a representation of the particle, something that has information like the position of the particle, the speed and the direction it is going, and maybe the color. And with all of that information, you put it into a compute shader, and you make the compute shader calculate the next position based on the information that it has, like the speed, position, color, etc. And the compute shader outputs a buffer with the updated particles. After that, what you do is that you create another graphics pipeline that reads from that buffer that the compute shader just output, and using that information as the position of the vertex, it draws some mesh. And at first I was drawing just quads to test, but because this is a whole new graphics pipeline, you can actually send any kind of mesh and use the position of the particle to know where to draw that mesh. And that way you can basically have a particle system that can show any type of mesh in the behavior of the particle. Be honest, when you think about AI of an NPC, you probably think about a bunch of if statements, right? I mean, that is one way to do it, but when you create a complex behavior like the one that you're seeing on the screen, that can become pretty unreadable and unmaintainable pretty fast. So I found a pretty cool concept called behavior trees, and more specifically in my case I wrote a binary behavior tree. And it is super cool because you can define behaviors as a set of nodes, and you can go to either of those nodes based on conditions, or you can make a node just to execute something and go to another node, or you can even make a node keep executing something each frame until it's done with something and then go to another node. So the whole system is really scalable, readable, and it is pretty easy for you to create behaviors because you are basically just writing plain English. And last thing, the debug rendering, the debug renderer. So this is just a pretty simple graphics pipeline that uses lines to render stuff. So I don't send them vertex in a way for it to to render triangles. I send them in a way for it to draw lines. And this is pretty useful because I use this small part of the renderer as a visualization tool to draw simple shapes like cubes, planes, circles, and stuff like that. And when you are creating a game from scratch and you don't have UI, you need a good way to visualize what you're doing because everything is in code. So obviously you can just write stuff and run it and see what happens, but if you can see it, it is normally easier for you to figure out what is happening or why something is working. And there you have it. Everything I developed in the past 2 months for this project. Basically, a game without game engine from scratch using C++, Vulkan, GLM, GLFW, without using any AI or framework or again game engine. I'm having too much fun with this project. I just wanted to share, and if I'm being honest, I wanted to give me a little, pat in the back because I'm pretty happy with the progress I have so far. This is the first time I am trying a project this big, but this is not the first time that I am learning and implementing computer graphics. I have years of trying to learn this stuff, and this is the first time that I try to put everything that I know into one project. And yeah, I want to create a world that feels like it's alive without having the input of the player. So when the player appears, the world should be doing something already, should be coexisting, should be living, and the player will just experience that small part of the world, from inside. I do have some story that I want to implement in this game. This whole idea is super random, but there is a story that I want to share with players. But I cannot tell you about it because I will spoil you the game. But yeah, if you like the video, if you like what you're seeing, if you feel like this is interesting, definitely hit the subscribe button, click like, let me a comment telling me what you think or what I can do better, or just whatever you have in your mind. So yeah, thank you very much for watching again, and peace.